back. This is a lecture on your flux core. Basically what we're going to talk about is how to set the welder up, maybe how to put a few welds in and things like that. So basically flux core is basically, you're going to be using the same wire feeder. It's either a Miller or Lincoln. You're going to be using, the only thing that's really going to change is the wire and your gas. You're going to use the same power source and things like that. So when you think about flux core, number one, it's kind of like stick welding, where when you lay a bead, there's actually flux in the wire itself, and as you weld, that flux floats up to the top of the weld pool, and it solidifies and it covers the weld. So in this process, you're going to actually have to, once you're done welding, you actually chip off the flux and look at the weld and go from there. The number one thing about flux core, it's like we said, it's like stick welding. So as you're welding, you're actually going to be welding in a backhand progression. So here's my nozzle wire coming out. So I'm going to be welding in that direction. So a flux core, it's a backhand weld. There's a few times where you can weld it forehand. But as you're welding forehand, for example, if I'm going in this direction, a lot of times that flux wants to fall out in front of the weld pool, get trapped in the weld pool, and gives you slaying inclusions. So typically when you get into industry, when you're welding with flux, everything's going to be welded in a backhand progression. Setup for flux core. Flux core, you're going to be using flux core wire. So let's kind of go through that while we got it here. Typically you're going to be using E71T-1M or 9C. We'll go over what this stuff actually means. First of all, just like all your other, E stands for electrode. You notice there's no R there. We cannot use this wire for a filler rod for TIG. So it's just an electrode. A little bit different configuration for your tensile strength. Typically this is going to be 70 thousandths. Basically it's 7 times 10 thousandths. That's going to give me my tensile strength. It's not going to be 71 thousandths. Now that 1 tells me the positions I can weld. 1 is all. 0 is flat and horizontal. Very important. So if we had an E70T, that wire is designed to weld in flat and horizontal positions only. Why do they do that with flux core? Because a lot of your wire diameters are getting very big. You'll get up to 1/16, 5/32 flux core diameter wire. That's the size of that wire. So when you start getting into 1/16, that 5/32 wire, you can't weld out of position with it because you have so much metal going in, it kind of droops down. T stands for tubular. This is the wire, keep in mind. Tubular, we kind of went over this a little bit in your filler metals section of your GMAW class. T stands for tubular. That means that wire is it's tubular, and there's either flux on the outer side or the outer shield or inner shield, it's called. So make sure when you go to the wires, you look on here that says E71T, and that's the wire that we're going to be using for this class. Now, when you start getting, after that little hyphen right there, when you start getting to the 1M, the 9C, those also mean something also. So if it's a 1M, that means that we're going to be using a mixed gas. That means typically 75% argon, 25% CO2. If it is just a C, like this 9C, that C stands for straight CO2. That's what you're going to be welding. So each one of these things, when you identify the electrode for flux core, means something. E stands for electrode. That 7 tells me it's multiplied by 10 thousandths. 70 thousandths tensile strength. It's either going to be a 1 or a 0 there. That tells me what position I can weld with that wire. That T tells me it's tubular. T is very important because once it's tubular, it's automatically flux core wire. When you go past that hyphen, it's 1M. M stands for mixed gas. C stands for straight CO2. Very important to identify this wire and what type of gas that you're using, what type of welding positions that wire is designated for. Very important. Very important. So now that we identified the electrode, the wire that we're using, remember the definition of electrode is that it carries the current. So our electrode here, for example, is going to be this wire, and it's also going to be used as our filler. So now that we understand that the wire that we're going to be using, let's kind of go through a weld station setup. FCAW. Let's go through like 045. We'll start with 045. That's the wire diameter. We're going to be using E71T-9 or 1M, 1C. A lot of these wires too, you can run them both straight CO2 or mixed gas. So we have our wire, typical gas that we're going to be using. I like to use 75% argon, 25% CO2. Flow rate, I like to crank mine up to about 40 to 50 cubic feet per hour. Volts. One thing about flux core wire, it's pretty versatile. Typically you can run anywhere from about 23 to 27, 28. My wire feed speed, inches per minute, I like to run anywhere from like 250 up to 450. Now this is something that when you get in the lab, you're going to have to play around with. My favorite setting is like 26.5 volts and probably like 380 inches per minute. I find that works pretty good for me. It may be different for you. You may want to start out with this setting, with this gas, run it, see if you like it, and go from there. The main thing about these lectures, and even in GMAW and SMAW, as far as the lecture reported for each welding process, is that you understand that you can go set that welder up to make it do what you want. That's the most important key that we want you to take away. Now, flux core, like I said, when you start doing multi-passing, make sure you clean that flux. You might have to grind the toes of that weld, even when you're doing your bend test. It's got to be super clean. Get that slag off there, make sure it's super clean before you put your next pass on. You can't weld right on top of that flux. It's going to cause you to have slag inclusions. So this is basically a setup that you're going to be doing out in the lab. The wire diameter, your gases, flow rate, volts, inches per minute, your wire feed speed. Now, keep in mind, if you're using 045 wire diameter, you got to have them 045 drive rolls and an 045 contact tab. The drive rolls that we're going to be using for flux core, they're knurled. They got little notches in there so that they actually grip that wire a little better than the smooth drive rolls. Make sure you switch that over. When you get out in the lab, if you're confused to setting something up, always contact your instructor. He will walk you through the setup, and when he walks you through that setup and then you start welding and you find something that works for you, write those settings down. Write what type of gas you're using, what type of flow rate, your volts, your wire feed speed. Write all that down. Even for GMAW, for any welding process, write it down so when you come back for the next lab period, you're not spending a half hour trying to get that welder dialed in. Basically, it's almost identical to spray and short arc. You're using the same power sources. The only thing that really changes is now that we're going in a backhand progression as we weld, and we're using different wire. So, hopefully this was helpful. Your test is going to be based on this lecture. I know the book gets into a lot of deeper things. But this here is what I want you to remember when you leave from your flux core class. That you can walk over to whatever welder you're using, you can set it up, and you can make that welder function the way that you want. Alright, thank you.